Hello everyone, my name is Mauro Tito and I will talk about my final project for big data application architecture. So what I have here is a project that tries to resolve a problem that you're going to have if you're going to drive here in Chicago. I'm not sure about other cities, but this is totally true in Chicago. So when you're driving and you're going to a specific place, let's say in downtown, for example, so the first step is find a parking spot, and that could be really difficult sometimes. So there's I would say you are going to lose some time because you're going to try to find a parking spot on the streets because it's cheaper compared to private parking spots. And second, if you're not able to find it, you're going to spend a lot of money renting a place to just leave your car there. So this is a problem of money and about time. I would say most about time than money. So with this solution, you're going to be able to know in which place, which is the closest place to your destination where there is a parking spot available for you. So we have here the Chicago parking spot finder. Um, we are using Lambda architecture. So to put it very simple, we have a batch layer, speed layer, and then a serving layer. So what is the batch layer here? Well, this is not real data because we don't have like live video cameras outside, and there's no public live cameras outside here in Chicago. So this is just 5 rows with five different places like Millennium Park, Navy Pier, Lincoln Park. What else do we have here? The location and the total number of spots in these locations. That's the batch layer. That's it. It's very simple. We are using Hive and HBase. For the speed layer, we have two sources. First, we got, well, there's a public live camera video. This is not from Chicago, this is from Colorado. We are using this to get the total number of parking spots available for the first place. So the first place here is Millennium Park. So if you see here, the last updated is 5 p.m. 10 minutes right now, and the last update was just half a minute ago. So it's going to update every single minute. And how are we doing it? Well, we are using a machine learning program to detect number of cars. Also, with that number, we are going to detect the number of parking spots available. This is not a perfect number because we need to tune the model. We tune it some hyperparameters, but it could be better. But I would say this is good for this project. But if we want to try this on in real life, we need to improve the machine learning model. And second, as we only have one video camera, so we are only updating this for Millennium Park. So if we update this table, now we got 8 available spots, and this was updated just right now. So for the other uh, locations, we have a form where we can update. For example, let's say the last one, Loop District Garage. So we have 2 spots available, but let's say that we are there. We can see, oh, there's not 2 spots available. There is 5 because there were 6, and then we go there, and now there is 5. We can update it, and we can go back to table. And now there's 5, and the last update is 5 p.m. 12 minutes. So that's how this works. Um, the idea for this is to not only see this table, but to have a map. So we got a map here. For example, if we are here, we can tell where is the closest place where there's some parking spots available. Yeah, that's it about it. About the last part, server layer, that's what we use. We have a Node JavaScript web app. We have a web user interface. For this, we are using Amazon Web Service. As you can see here, well, both of them, the batch layer, the split layer, and the server layer are on Amazon Web Service. And this is the link. Unfortunately, you cannot access this link unless you have access to the server. So if you are not part of the Big Data Application Architecture course at U Chicago, you cannot access this, but this is what we have here. Thank you so much.